Hey, welcome. Welcome to this Sans live stream. My name's Phil. We'll be spending a little bit of time with y'all and also want to introduce David. Hi, David.
Hello, everyone. My name is David Szili. How's it going?
Hope you're all ready to get some cool info that we're excited to share with you on network forensic tools at scale. Got a lot of fun stuff lined up for you. Let's go ahead and bring up the start of our slides over here. There we go. So yeah, network forensics, definitely something that's near and dear to our hearts. We're excited to chat with you here today. As you're in the live stream, we've got a bunch of ways to communicate with you. So please do drop comments in there because David and I will see those and try to get to them during the conversation as well. Let's do a little bit of intros just to kind of get that out of the way. My name is Phil Hagen. I am the course author for one of Sans courses, Forensics 572, which is all about network forensics. Go figure. That's how we got to this live stream here. I'm also been working with SANS in a variety of capacities for quite some time. I've been teaching for about 7 or 8 years now, been working with SANS for about 10. Also get a chance for part of my day job to be the head of our relatively new research and development team, where we're doing all kinds of amazing work for all of our courses, not just the DFR courses. And I get to work with the awesome team over at Red Canary, our flock of canaries, which some of you are joining in today. I get to support our community team, which is bringing cool information out to the masses. Also works really nice with what we're talking about here. The stuff we got down below, I live in Delaware. This is where the Delaware joke comes in, but I'm in the Delaware Beach area and I have to put hops up there because I'm just a big fan of craft beer. So although I am enjoying a delicious bottle of water here with us today at the live stream, always eager to talk about that too. David, give us a little background on you as well.
Sure thing. So my name is David. The correct pronunciation for my last name is Szili. Yes, like the English word, because it's a Hungarian name. I was born and raised in Hungary with a couple shorter and longer breaks. I've been living in Hungary. We actually recently moved back to the country about a bit over a year ago. And I've been teaching for since, I want to say 4-ish years. This is probably the 4th year now. I'm a certified instructor and I teach the 572 class, also getting involved with the cloud forensics class. That's the 509 one. And I'm also the lead author for the D4 Networks game. Not sure if anyone is familiar with the networks games that we have. We have different modalities for networks and different versions of it. And we have a DFIR specific one together with 3 other authors. I'm the author for the question sets and data sets that you can encounter if you take the challenge and either play the tournament version or the continuous version of it. And I run my own little consulting company together with my partner in crime, wife, Eva. That's all the information security. And when I looked at the slide and saw the hop image, I just thought that, okay, that's going to be an easy one because we have a shared personal interest. And I'm very happy to see that once I returned back to Hungary, I came back to a country that has a booming market of craft beer. So there are some local ones here in the city. There are some local craft breweries. I'm still exploring. There are one that I kind of like, but there's still much to discover as well. And I see some familiar faces in the chat, actually. So
Yeah, I was noticing a couple of those as well. I see some former students and stuff in there, which is pretty cool. Yeah, so I'm super excited to kind of chat about this with you. David and I have been working together on both teaching and forensics 572 stuff for quite some time, and it's always a good opportunity to kind of chat about some fun things. So let me go ahead and kind of get started here. We're talking about at scale, and I want there to be 2 main points. Network forensics has a whole lot of different facets. We're talking about network forensics at scale, so think really, really large collections, and on a budget. And so many times those 2 things don't really go together. And we're going to talk about 3 different ways where you can do large scale forensic analysis on network data without breaking the bank. So that's going to be a big component here for us, those two main themes. When you first think network forensics, I would say overwhelmingly the number one tool that folks say, oh, I know network forensics, I use blank. I don't know, David, what do you think? You get this same answer with folks that are either new to the field or new to network forensics?
Absolutely, it's always one go-to tool.
This is Wireshark, and
which is reasonable. I mean, that's the tool that you use for network troubleshooting when you're looking at problems on your network. So that's probably the tool that everyone is familiar with. You see it in movies even appearing.
And I mean, let's face it, it's amazing, right? We use it all the time for a lot of different purposes. I just pulled these numbers out of our classroom VM. It's probably actually larger than that by now, but Wireshark will parse 2,500 protocols. And I jokingly will always say stuff like, if you as a human being can parse 2,500 protocols in your brain, we need to have a chat because we need to find you some new hobbies. That's not a good use of brain cells. Use tools to improve our ability. Love Wireshark, does a lot of absolutely impressive stuff. The fact that it's got the graphical interface that lets us explore all of the content and follow the streams and do all that work kind of automatically is pretty great. I don't know. What's your estimate? How many times a week do you think you fire up Wireshark on a given week or given case?
Oh, that would be difficult to count. Probably every second day for sure, almost. So yeah. Work a lot with packet capture files, and Wireshark is also my go-to tool, but within reasonable frames, because I think we're going to talk about that.
Yeah.
There are certain limitations with Wireshark as well.
There's always limitations. There's always a catch, right? So the ever-present, but it's really designed for a specific use case. It's best used for examining and exploring protocols in a limited set of data. I generally say if you get get beyond about 500 or so megs, Wireshark kind of starts to show its limits. And I did just find the other day an estimate that said you should probably have enough RAM in your system for 10 times the capture size you're trying to look at. So you get into a 2-3 gigabyte file, and holy cow, that's that's going to take some RAM to potentially use there. So it's really not viable for large collections. When we talk about large, that means a lot of things to a lot of people. I put small captures in quotes here because you can quickly get to terabytes, and people are like, "Oh, no, I'm not going to do terabytes. That's not reasonable." So here's my trivia. I like this one here. This link profile is kind of an interesting one. If you were to say, all right, I need to do full packet capture, so I can look at a 1 gigabit per second full duplex connection for a week, and it's only like 35% saturated. Like, that doesn't sound terribly unreasonable, does it? I don't think so. But if we take a look at that link profile that I've got down at the bottom there, let me go and tab over here.
Maybe we should ask the chat first. What do they think?
Oh, that would have been a good idea if I would have thought of it.
You already have that one prepared.
52, almost 53 terabytes worth, just for that link profile that we talked about, that 1 gig, 35% saturation for a week. And I say a week because when we think enterprise, we'd like to target like 2 weeks of packet capture. I mean, that's kind of an ideal situation. That's going to get a little bit scary. If any of you attempt to open even 1 terabyte in Wireshark, I'm sure that you're going to have a very, very bad time. So no disrespect whatsoever for the amazing capability that Wireshark provides for us, but go ahead back to my window here. We've got to understand the limits of any tools, not just Wireshark itself. So let's talk about a better way. We have to look at different types of evidence. Now, packet capture is fantastic. I always like to say that packet capture is my evidence of last resort, and the reason is it itself contains presents a lot of challenges for us. Large volume, terabytes required. It's sensitive data. That could be another issue. And this is actually an interesting point. Like, you being in Hungary, you've got a whole bunch of different legal constraints on data collection and such for cases that you might run that are EU centric. Can you kind of talk a little bit about some of the sensitivity there?
So it's been a while. I had a project in Hungary, but I do know some of the legal limitations from Luxembourg. I have most experience with there because I worked at a telecom company, and for telecom companies, there's I'm not a lawyer by the way, but I've been told by our internal counsel when at the time I was working for a telecom company in Luxembourg. And the legal limitation there was for retention time was 6 months max. And I talked to ever since I worked there to a lot of folks, and that seems to be the norm. I can't remember if Germany has the similar kind of law, but after 6 months, you have to delete the logs. But even 6 months worth of logs is pretty good. And if you're thinking like you can outsmart the lawyers, and because I tried it and tell them that, well, we collect NetFlow records and NetFlow is not logs, then they're just gonna say, yeah, nice try, but it still counts as a log in their eyes. And when it comes to GDPR regulations, but I don't think that's now EU specific. There's also the help me out if I'm not recalling it properly. The California Consumer Privacy Act, is that the one?
Yeah.
So yeah, that will also have essentially the same kind of restrictions on personal data because I believe it was derived from GDPR.
Yeah, they're very similar, and I will be honest. I'm not a lawyer. I didn't stay at a Holiday Inn Express last night either. But it gets super complicated. So we've got these legal constraints. We've got just technical constraints. I mean, I got a pretty beefy NAS in my little lab storage back here behind me, but I'm not going to be able to store 54 terabytes worth because I just don't have that volume of storage. So we have to look at
Yeah.
other sources, and you mentioned a couple of them too. So you mentioned where's my clicker? There we go. You mentioned NetFlow. You mentioned log data. Yeah, absolutely. That's a big deal to augment your packet capture. So these three different buckets of evidence are what we generally say are our bread and butter in the network environment here. We're going to talk a little bit about each of these in turn, but where you see these icons show up, this is going to be when we're talking about each different type of evidence. And I mentioned these for a couple of reasons. First of all, we use these logos here within this material. Also, happen to have a nice copy of our network forensic poster sitting right here. You can actually get this in PDF form at the URL down at the bottom. Also includes a detailed look at what those three different types of evidence are, as well as their use cases. That's one of the free resources we've got for you. So always like to point those out as well. So hopefully that's something you'll have a chance to check out with our poster in PDF form. And you can pick up the giant rolled version if you'd like to as well. But we're going to talk about tools that address each of those different types. And I want to be really clear here. This is we've got a 1 hour live stream. We're not going to cover the thousands of tools that are out there that address these. So these are a representative sample, and we really wanted to focus on free, focus on scalable. That's kind of what brings us to where we're at right now.
Yeah, I saw it in the chat. Drex is from the Philippines, where budget is always short, but I think it's a common theme. It's not specific to
Absolutely.
the Philippines. There's always that's the one. So it's not really specific to the Philippines, I'm afraid. And just storing the volume that you saw with that very very discrete and almost like toy example of the 1 gigabit per sec link that requires serious hardware, especially if you want to keep up with the speed or just have a longer retention time. Then you're going to build out. I can't remember. Was it in our Slack one? Someone dropped in a link about a rig that was capable of storing some horrendous amount of data, like petabytes, or what was it, you or?
Yeah, it might have been. And actually, it was the biggest installation that I've seen in person of packet capture at scale is this tool, is Arkime. So yeah, it was multi-petabyte. The one that I linked to was about 2 petabytes worth of storage. Um,
Mm-hmm.
not happening on my NAS back here. I don't know about you. Maybe that's a you've got drives in your drawers behind you, but I don't.
Some, yes, but but not that much. But the cool thing with Arkime, I think, is that it's really purpose built and tried and tested. I had the fortune to uh, prepare a bit for the D4 Summit presentation with Andy and Elsie when they presented the platform, and talked to them a bit on about Arkime. At the time, it was still called by the old name Moloch, and it's pretty amazing that they built this platform for their backend, uh, which was at the time AOL. Yes,
Right.
that AOL,
Yeah.
which is now Verizon, part of Verizon Group, and it's really a tool that was tried and tested, and it works because it was working in an ISP's backbone system, and it scales. Obviously, you don't have to have like infinite retention time, but it's really an amazing solution.
Yeah, so it's let's talk just a little on what it is to start with. Arkime, free open source tool. You mentioned the developers, Andy Wick and Elise Rennie, fantastic folks to work with. Very, very good community stewards of their tool. It is a full packet capture and analysis system. What I love about these kinds of tools, all of them that we're going to talk about, is I say that they support both the DFIR and security operations workflows or models, meaning that I can take existing data, in this case packet capture, load that into Arkime and do the same thing I'm going to show you in a little demo here, or I can use this in live collection mode, so it can be your actual collector, which is actually what I'm gonna show you here coming up in just a minute. Um, It'll actually read in that network data. It parses out a whole bunch of metadata from probably about 30 different protocols, writes that metadata down to Elasticsearch, which we're going to cover again in a couple of minutes in a different tool. It's really going to give you that best of both worlds, where you've got the low level raw collection and you've got the metadata that you can search super fast. So that's what I love about this. It's a tool that you can deploy out pretty quickly and have an opportunity to start playing with, because again, it's free, which is pretty awesome.
Yeah, on the deployment side, they have, I think, a shell script if you just want to have a single instance deployment. And I think aside from pointing it to an Elastic cluster and maybe providing a password, that's all you have to do. it's
Yeah,
it's
it's
super
super.
fast. So if you want to just check it out, or you're okay running it as a single node um, deployment, then this can be up and running in no time.
Yeah, definitely. Well, screenshots are great, but it wouldn't be a fun live stream unless we tempted fate, haunted the demo deities, and go ahead into a live demo. So I'm going to kind of walk you through this one and give you a little bit of perspective here. This is the main Arkime session viewer. I actually have this running in my lab here, doing complete full packet capture of all traffic in and out of my environment. So what you're seeing here is live, and by default, you can see the last hour worth of data. But I want you to get an idea of scalability here. So you can actually bring this up to show the last week worth of traffic if you want. Hey, I just went ahead and looked at an entire week of packet capture on a relatively busy network, not enterprise here in my environment, but about 100 or so endpoints. We're running somewhere in the vicinity of 4 to 5 terabytes a month worth of traffic, and we can even expand that out further and further. It's a brand new node, so I only have a couple of weeks in here right now, but I've actually had this running for up to a year in the past. And whether or not all that PCAP and that traffic capture is live online doesn't matter, because that metadata that it parses out goes into Elasticsearch, and you can then query that, without the underlying packet capture. But wanted to show you a couple of cool things that I've picked out from. I'll go with the last 48 hours just so it runs a little bit faster. What I like here is you got this, session count over time. I like to go over to data bytes. Now, for those of you that are familiar with Wireshark, you'll see some of these colors look fairly familiar. The red versus blue, which is the directionality of those packets. When you go to data bytes, it's just the payload. So you can kind of see these time frames of when there were a lot of transfers, and obviously the spike that comes up there. And if you're interested, you can kind of zoom in on those. It'll kind of pivot back to that pretty quickly. And you can see here that we've got a quick view of just this, let's say, with whatever the duration is, about 4 hours duration of time that we pivoted onto pretty quickly. So really fun to be able to explore your data, which I think is a big deal. Now, where it gets really neat is when you're searching. So not only are you looking at these where every single row you see is a different session of text, I can go ahead and search across a whole bunch of that metadata. So I could actually say TCP port. I'd like to find the port equals port 80. Show you a couple examples here. And we just pivoted down to that pretty quick. So only the sessions that match. Now, I've got a couple of things that I didn't stage necessarily, but I did a little bit of research ahead of time to find some interesting sessions. Let's take a look at one of these to begin with, though. So let's open this up, which is an update for one of my CentOS VMs. You can see all this metadata, which they call spy data, by the way, session profile information. But this is all what's parsed out of that original source, that original traffic. And because this contains HTTP, you're going to see a whole bunch of other things in the metadata that are parsed out for that field, that protocol specifically. Now, before I go down, let me pause here for a second. If I deleted the PCAP or I ran out of disk space, so I kind of aged that out, this is where the view would end. So the spy data persists in your Elasticsearch database, right? If you still have the PCAP available, Arkime is like, cool, let me show you the actual traffic. And we scroll down a little bit and you can actually see all of this traffic coming in, and you can then go ahead and review what the content was. So that means I've got full access to that, which is pretty slick. Now, I don't know about you. Do you like parsing XML visually, David? Is that a hobby of yours?
Yeah, well, not only visually, but I don't like parsing XML programmatically either. So
Fair point. Yeah, absolutely. So this isn't the demo that I wanted to show you, but I wanted to at least show it like, hey, we got full content here, the back and forth across this HTTP keep alive connection. We can do all kinds of neat stuff like, ooh, this session is interesting. I would like to download just a PCAP of that one session. There's a great way to feed that into Wireshark, for example. Or we've got a couple other options that I'll show you with a different example. Where I wanted to show you this. Oh, go ahead.
no, it's just I also saw this in the chat, and I think it's a good point here to kind of take a note of the fact that one of the reasons why you might not want to open up a peak, even if you have a PCAP, you don't want to jump in and go with Wireshark first, is that it's just a lot of data. So we and you will see this as a reoccurring theme probably with all the tools that we're going to demonstrate here, where whenever we start an investigation, we will look for ways to create leads that we can then take down and maybe do a more in-depth analysis and just get the relevant part of that packet capture if it's available. And someone, Brutus in the chat also mentioned that that they usually start off with network logs and NetFlow, and then maybe PCAP if it's an ongoing incident that they going to start packet capture and try to capture the malicious traffic that way, which is I think it's a great approach. And this demo here with Arkime, I think, also highlights the fact that by looking at this parsed data, the spy data, it becomes a lot easier to identify the relevant parts of the traffic.
Yeah, absolutely. And you're able to pivot within the time frame you're looking at and search based on what I wanted to show real quick here. if you take a look at the number of fields that are possible, this is just a small subset. So that spy data comprises of quite a lot of potential. However, if we were to term MIME type, same thing. They just call it a little bit different. I'm basically looking for anything that starts with image. Now, what's kind of cool is, well, number one, I took just a couple of entries down and pivoted that here. And then, here's a good example. Let's see. Let's take any of these images, like, now let's go to this, FOR572.com. Now that's CSS. I had one that was really cool, but it's down to the raw content. You're like, all right, well, I can tell from this that you're looking at a JPEG. Great. I don't know about you, but can you tell what that picture is? I can't. So we can
Not
do a
really.
couple of things. We can extract the PCAP, open it up in a different file, pull out the HTTP exchange. On this, we now can see that, Kindle books here. Somebody, somebody's looking up different Kindle books, and this probably my kid's looking at books. Now it's actually rendering it natively, which means I don't have to go ahead and do that post processing at all, which is super convenient because it saves me a bunch of time. And David, you know this about me. I always say, I'm not lazy. I'm efficient. Big difference there. Efficiency is strategic laziness. So.
Although that's also the feature where you need to remind yourself if you're doing forensics.
Yeah, you probably want to be a little careful of that. You don't necessarily know exactly what images are in your case data.
Yeah. But I do think that's an awesome feature. There's also one feature that I really like, and I'm pretty sure if someone is not familiar with Arkime, then they might be interested. Like, can I take that data to another tool, if you know what I mean?
Right. So are you talking about the on-platform thing?
Yes.
So
can you show that one as well? I think
yeah,
that's a killer feature.
it is. So you can see here, I'm still looking at the actual file. Now let me go ahead and turn that off. So I actually look at the raw content. Okay, so this looks like it's some JSON data, right? You and I can start looking at this and get a feel for it. And if you're not familiar with JSON, it's a very widely used format. We're going to talk about it more in a minute. And I can actually take these and open up with an on-platform instance of CyberChef. If you're not familiar with CyberChef, earmark this one because it's fantastic. It's this, what they call Swiss Army knife for data. And you get all these different recipe components on the left that you're able to then embed into this sequence to do some decoding. So I like this one. If you can see, I've got an HTTP response, and if I want to get rid of those headers, I just go and grab this recipe item, bring it over, and there we go. We've removed that. I can take JSON, and I can say, I don't want to look at that in compressed mode. I want it to look pretty. I want to pretty print that. Well, there we go. Now we can see everything a little bit better. This is actually an update for my solar panels on the roof. Or no, I'm sorry. I was looking at that earlier today. This is my water sensor in the crawl space alerting me to whether it's got a problem. And if for whatever reason I wanted to just get the value that's here, battery percentage, I could actually do a JPath expression. That's going to just be for the dot change value. Turn that one on. Oops, no, not a dot on there. There we go. So we just pulled that value out and we're doing some JSON parsing. This is just one example, but for those of you, and I see some comments in here coming from YouTube of like, yeah, CyberChef's amazing.
Yeah.
Holy cow, CyberChef's amazing. You can do so many things with it.
Yeah, and this is a great example for what these tools can do for you in terms of pivoting from even one tool to another, which is a very powerful analytics workflow.
Yeah, absolutely. And the last thing I'll mention on CyberChef before I jump back is these recipes that you have here. You can actually save the recipe directly back onto the Arkime instance, which means you can reuse the recipe. This is a very simple one, but you've got potentially 10, 20, 30 different recipe components here. That's going to save you a lot of time. You don't have to recreate it or re-explore it. You get that recipe built directly in. Now, there's a ton of other stuff in Arkime. Looking at the time, I want to make sure we're giving time to the other tools that we've got lined up for you as well. I just really want to stress here, Arkime gives you that massive scalable approachability to large packet capture component or large packet capture data stores, and the ability to do all these processing steps after the fact means you're now able to explore that at your convenience, or more likely, as you kind of hinted at earlier, when you gather a lead and you want to chase that lead, you learn more about stuff as you get deeper into the evidence, and then you can kind of go ahead and look back at your existing data sets. Pretty cool stuff.
So in the chat, Vicious is asking, what tool is this? We just went through Arkime here.
Yeah, Arkime. And there was a question earlier about it being, is it similar to Moloch? It actually is the newer version of Moloch. They renamed it Arkime, kind of did a little bit of rebranding, got a cool new logo there. And same thing, just new version and a whole bunch of new features with version 3.0. That brings us to the second part. We're going to talk about a different type of evidence. We're going to talk about NetFlow. And for those of you who've had me in class or pretty much ever talked to me about network forensics at all, you know that I unapologetically say that NetFlow is without a doubt my #1 most favorite source of network evidence. It is my go-to. It is what I will prefer over all others. Let's talk about what it is. It is a statistical summary of a communication that's occurred in the past. By definition, it throws away the content and summarizes the headers. Now you might think, whoa, hold the phone. That seems like you're missing some important stuff. Like, I don't know the content, right? Right, absolutely. But what's the value? Size, speed, less sensitivity. I can run queries against NetFlow that are sometimes thousands of times faster than I'd be able to run against the corresponding full packet capture, the full traffic capture. And a lot of times our questions that we need to answer don't require content. If I'm looking at large transfers or communications with, let's say, your threat intelligence informs you of bad IP addresses or IP ranges, I don't need to have content to know if I was communicating with those. So that's really, really helpful for us, and gives us that opportunity to just go at the data very, very quickly. I'll give you one example here. So if I'm running, I actually pulled this out of my lab capture here. This is a tool called NFDump. We're actually not going to talk about this one, but I did want to show you at a command line how fast it can be. This is basically me running a query against a 24-hour set of NetFlow. And I wanted to say, all right, show me the biggest transfers within that 24-hour time period. And the results here, like, you can kind of muddle through and see, all right, I see some IP addresses and some ports and such. Where I really want to focus your attention, though, is over here on the byte column, where those are some pretty significant transfers, right? Those are non-trivial. And I also want to draw your attention to the fact that in this 24-hour time period, my lab had 54 gigs of network data. So this NetFlow file that we're looking at is a summary of 54 gigs worth of traffic. We ran that query in 0.3 seconds. That's no joke, right? That's a pretty significant speed up there. You'd never really be able to run at 54 gigs of packet capture in that amount of time. If you can, I really would like to see your hardware setup. I don't know. That seems pretty fantastic, right, David?
Yeah, so that speed you cannot even achieve with just using a simple BPF or anything like that. That's really the amazing thing with NetFlow. The other thing that I do like with NetFlow is now it is an evidence type that you can have access to quite easily in cloud environments. Probably even easier than in on-premise cases. Although I always like to give this pro tip to everyone that if you think you do not have NetFlow, you should ask your network team, because I'm I'm pretty sure if you have a couple of network engineers, they do use it for their
Oh, yeah.
purposes at least. But in a cloud environment, you will encounter the same data type. And this is the one that you will have first from a cloud provider, even if they don't have any sort of network visibility. That's the first thing that they usually enable. On the break-free platforms, you definitely have that one. And it's the same speed, the same analysis methods. NetFlow is NetFlow everywhere. Depending on the flavor, you might have additional fields and more context, but essentially you will do the same thing. You're going to run queries against it and do some aggregation to find outliers, like Phil said, some of the examples here. And another great use case for NetFlow is when you're looking at lateral movement, because really there, the most often the context is something that comes after you detect or suspect that there are traces of lateral movement on your network. So absolutely fantastic data type. I'm also a huge fan of it.
Yeah. So let's shift gears just briefly out of NetFlow specifically. I promise we're going to come back, but let's talk about a platform that not only can help on NetFlow, but it's something that I think is helpful for beyond just that one data source. Talk about a distribution of the Elastic Stack that I created originally for Forensics 572. And then we kind of built that out to support other courses as well. And since you're now going to be teaching our cloud forensics course with Forensics 509, you get some unique perspective on that as well. I'd created this as kind of a boot and use Elastic Stack. Elastic Stack's fantastic tooling, gives you big data analytics, but it's a little complicated to potentially deploy, maintain, to get an understanding of the architecture on. So we just kind of commoditized that, packaged it up into a VM. You got the URL down at the bottom. You can download that VM probably before we're done talking here this session, and start using it almost immediately. Boot in VMware, you're golden, right? So although we're going to talk about this in the context of NetFlow, quick little demo on that for you before we go into our last evidence source. I did want to let you know that this is something that is available for anybody in the community. It was created for our courses, but we release it as a community capability. So what does it consume? What can you analyze with it? Well, there's a ton of different ones that we've built in and keep adding more and more and more. In fact, I just added some for the new Forensics 509 version in the last week. We can parse syslog, and out of that, there's a bunch of different sub-processors that you can run. We're going to show you NetFlow. The example here with web server logs. I just want to point this one out for you. We're talking about addressing 16 million text records. Question on what tool I'm using here. It's actually called Snipose. It's super, super helpful. I think it's Mac only, but man, I love this thing. So 16 million records that we're looking at here. And to be able to examine, in this case, the timelines that we've got, here's the request methods from the HTTP server logs and the response codes. I'm not going to do this out of 16 million lines of text. I'm sorry, it's just not in my brain space to be able to do that. This makes it super easy. And as you're going to see, it's also interactive as well. And of course, everybody likes pretty pictures. We got dashboards and visualizations and all kinds of other neat things that are a part of it. But let's get that into the NetFlow world, because one of the evidence types we can parse out of here is NetFlow. And it's not just a live collection of NetFlow. We can also bring in a whole bunch of archived NetFlow as well. So here's the different types on here. You were mentioning some of the different cloud logs. What format do those usually come in on, David? Those cloud NetFlow logs.
Oh, sorry, come again?
What format do the cloud NetFlow logs usually come in?
The best format that is out there. It's usually JSON.
So it's usually JSON. We kind of touched on that before. We're talking about it now. I don't know. Maybe we're going to see that in our next tool. We'll see about that.
Could be.
Almost like I know what's coming.
If I don't forget to include the policy name, then yes.
So so here's the NetFlow dashboard. And I'm going to show you this in just a minute here, but the idea is this is looking at, you can see here 3.6 million flows of traffic. That's a pretty cool way to be able to examine that from a visual perspective. So I want to get over here to the browser to kind of show you what that looks like, just to give you an idea of what I've got loaded up. There's your 3.6 million records, and I've got a bunch of other ones for HTTP server logs and such. But let's say we want to go to NetFlow because that's the section we're in, show you a couple of value propositions. So this is hitting actually our class VM. And you can see here, it's taking a second to load up all that data first because we do have almost 4 million records to go from. But I've got this specified at the last 15 years. I cast a wide net. That's not really going to help us very much. So let's go ahead and narrow in on the time period that we have covered. And we're able to now pivot in. And I'm going to probably do that a few times to get us a little bit wider view of this traffic that's in the data set here. And this is actually coming, like I said, from Forensics 572. So, David, I'm sure some of these traffic patterns are going to look familiar to you, seeing this all the time.
They do. I know every traffic spike in that data set.
You've got, oh, yes.
I don't even see the data set anymore, just TCP and
It's
UDP.
all
and
in green
it's
characters.
just, yeah.
Well, as we take a look through here, being able to see this in three different views, three different metrics. You got the byte count, which means this one right here is a large transfer. We've got, a 12.8 gig volume over the course of 3 hours. That's super easy to tell visually, right? Same thing over here, the number of individual flow events and then the number of packets. Of course, we've got a corresponding spike in here during that same 3-hour time frame, but it's interesting that we've got two other spikes that are much larger number of packets without a similar corresponding spike in bytes and data, which means smaller packets, just more of them. I'm not going to get into exactly like what those significant factors are here because we are limited on time, but I did want to show you being able to explore this stuff spans out to our source and destination. So we've got our individual IP addresses here. This is great to find things like your bandwidth hogs. Why did this one system, 4.10 that shows up here, take up 26 gigs of traffic? Well, that's because it's a proxy server. And in this particular data set, I know that because we're familiar with it. But when we take a look at this other one, we've got now a system that's, one of our security admins in this environment who's representing 20 gigs of traffic. If I want to know what that is, I can simply go onto here. I can now add a filter. And I've taken that filter up at the top and saying, just show me the traffic from that source IP address, 5.75. And now I've narrowed down that 3.7 million to 3.2 thousand. It's a pretty good data reduction, right? Same thing over here on the source and the destination port. I can tell what the destination ports are. And visually, this stands out real easily because we're only looking at 3,000 or so flows. But I can now see that most of that is TCP/22, suggesting maybe this is SSH. I don't know. Want to see where that's going? We can click on this, and I can say, I want to build a new filter. TCP/22 traffic. It's going to go ahead and filter those. And now we can actually see, oops, sorry about that, scroll too far. We can see the destination IP address. I can see that on a map. GeoIP is not perfect, but it gives us a rough idea of where that may be. And now we've started to drill down into that data pretty significantly to maybe find out what that is. Why is there such a large transfer of TCP/22 going out of the environment? So, in moving further down, I do want to stress as well, and I want to zoom on this. Kind of like we had the session breakout in Arkime, we can do something very similar in Elastic in general. So SOF-ELK exposes this entire record. So every single NetFlow record that you have here is going to now be, all these different data points that you can pivot on, including location, IP address, volume. We can tell this was a 20-second flow for, maybe really long flows are interesting, maybe really short flows are interesting. NetFlow is going to give us all that without having any content behind it. And you can see how fast this is actually going. So overall, pretty powerful stuff. Is there anything you wanted to add in on this one before we press on?
I think you covered the most interesting points. I think the cool thing about SOF-ELK and probably Elastic in general is the visualizations that you get with. We had the example of NFDump, and it does have the value. I do like command line tools because you can script them and they're fast. but sometimes just visualizing the data helps you to immediately, like you said, spot outliers, anomalies. So I usually build very boring dashboards. Most of them look like the ones on the left-hand side, with the volumetric and packet aggregation there. But using something like a timeline can be a tremendous value to see traffic spikes, and you don't need the machine learning AI next gen solutions to do that. You can even just do it visually as an analyst. So, and
Yeah.
I don't know if you highlighted that one, but probably worth mentioning again that, like, if I want to get SOF-ELK, do I need to take a sense class to
No,
use
no,
it?
not at all. Again, it's a community resource. You just go to that URL, for572.com/SOF-ELK, free public download. You can go ahead and grab that. All the configuration files are in my GitHub as well, but it's all pre-plumbed and built into the virtual machine. So you don't have to build anything, but we do have some instructions if you'd like to do that on your own.
And I think that's the big part, the tremendous amount of work that went in with all the parsers there. So I actually worked on, just played a CTF that involved CloudTrail logs, and I grabbed it, loaded into SOF-ELK that I just downloaded from GitHub, and there it was. I was able to start the analysis. So I
Yeah.
really like it. It's really almost like a turnkey solution for your analysis needs. And yeah, do you know how many parsers you have currently? Just a rough number.
Overall, I think we're probably somewhere about 70 or 80 different ones, but we're adding more and more on. You mentioned some of the CloudTrail stuff. That's relatively new. I just worked with one of the co-authors for Forensics 509. Give you a little bit of preview in that coming up, where they're adding in GWS services. So we added a bunch of parsers to support that as well. And yeah, always growing, always eager to hear new requirements.
Yeah, there's the
So,
Viviana just pasted the link if you
yeah.
want to check out the SOF-ELK VM. That's where you can get it.
Yeah, absolutely. Hopefully, it's something that'll resonate with you. You can give it a try, kick some tires, so to speak. Well, that ends that demo. We got just a little bit left, and I want to make sure that we're talking some logs as well, focusing specifically on we're going to talk about one particular type of logs, but broadly, logs are fantastic because we get them from a lot of places. But you see that they're in just as many formats as you have sources, which becomes a little bit challenging. Similarly, there's lots of them. You could have billions of logs to potentially go through, and that's going to be a bit of a challenge. We're going to specifically look at Zeek logs. You want to give us a little bit of an insight to Zeek and what it's going to provide for us and the demo that you'll have here?
Sure. So when it comes to network forensics, probably you will encounter logs most commonly in a form of some sort of server log, maybe your DNS logs or web server logs. But I think it's getting quite common to have platforms that will provide you very often actually running something like Zeek or Suricata under the hood with logs produced directly from network traffic. And I wouldn't be surprised if you land in an environment, maybe in a consulting capacity of some sort, and you ask for these, and your client might actually have these readily available. I think logs are really a middle ground between full packet capture, that is really all the data that you observe, and NetFlow. So they're ideal to, again, generate those leads. But I also like to use these tools, and we're going to look at Zeek as an example. But obviously, you can use something like Suricata or newer versions of Snort, even Snort 3, to produce a more manageable, reasonable data set that you can slice and dice then to identify, again, where you want to focus on when you want to do an in-depth analysis.
Yeah, absolutely. And one of the things here is there's a lot of different logs that Zeek provides. So when we say Zeek logs, that's actually a pretty huge scope there. Here's a list of some of those. Don't let that be daunting, but some of these are a little bit more intuitively named than others. We talk about you talked about DNS logs and such. I would say in terms of formatting, though, historically these have been in tab separated values. Not my favorite. We've already expressed how much we like the JSON format. So this is my preferred format anyway. I know this is one that we try to use when we can, where this will be some metadata about that, in this case, HTTP exchange. This is actually my NAS reaching out to get some synchronization status, and you can see a lot of the familiar HTTP objects and some other interesting ones as well. But you got something you wanted to walk through briefly on Zeek logs, right?
Yes, I
All
have it
right,
actually here.
cool.
So what I have here is a pcap file that I just grabbed from the data set that we have in the 572 class, just as a demonstration of what you should expect from Zeek logs and how you can use these tools to sort of distill down pcap files. These are my primary go-to tools when I deal with just packet captures, and maybe I have an Arkime instance available that I can use to load in. But I do enjoy just quickly browsing through the Zeek data that I get from a PCAP file. Plus, these network security monitoring tools can also provide you with some additional value and speed up your analysis workflow. So what I have here the reason why I didn't start this full screen is I also want to give you a tip on, and we somewhere probably have the URL. I don't have it ready, but we also have a guide here, and you can find it on the Sense portal site for JSON and JQ. I'm going to use a couple of very simple JQ commands. I don't want to dive into too much in the tool because it's fairly complex and it has quite a steep learning curve. And we do realize that, so that's why we created this cheat sheet that you can check. And I think this covers, but I might be biased, the most important use cases for this tool. The PCAP file that I have here is, as you can see, approximately 350 megabytes. This one, if you're patient enough, you can load it into Wireshark, and I amped up a bit the specs for this VM, but a much faster way, in my opinion, is to use another tool. We saw Arkime as an example. Another alternative can be to use something like Zeek, and you can ingest a PCAP file by just feeding it into Zeek. Suricata has the same kind of functionality. Instead of multiple log files, Suricata by default will create one JSON file, and you have to do filtering, but it provides a very similar kind of data. So you will have flow data out of it, HTTP logs, DNS logs, SSL logs. And we also have for the class a profile that we use. This one, I actually like to use the class VM certain cases when I don't have a VM that is pre-configured with all my favorite plugins. The class VM actually has most of the favorite plugins that I like to use, and
Well,
actually
if you
choose
took
to.
your recommendation on which plugins to include.
So job-free hashes are definitely one of my favorite ones. The community. Should we? Can I show the? Can I show the profile actually?
We just have a couple minutes left, but
Okay. Then yeah,
but
I'll.
we
I
should
will
say that
just.
this VM is a variation on the free community SIFT version, but we've customized it to include a couple of specific things that are relevant to the 572 course, and we're working to make those a part of the community one as well. So it's going to happen in time.
Yeah. The configuration is not difficult. You really need to modify just one file. It's more like, for me, speeding up the process, and we already have the plugins pre-installed. We're talking about approximately 30 minutes of configuration here. So what I'm going to do, I'm going to use one of the profiles that we have, and this one shouldn't take a lot of time, even though, as you can see, the name says all files. And this will tell Zeek to use a file extraction functionality that is included, I think, by default with the Zeek framework. And this will go in, and whenever Zeek identifies a file, it will carve it out. And everything in this ingestion process will be created in the directory where I issued the Zeek command. And as you can see, it only took a couple of seconds here. The extracted files is the folder that contains the files that were extracted. And we have also here a set of log files. Now, these log files by default will be tab separated if you don't specify it in your profile file. The one that we had and the one that I ran Zeek against is going to produce JSON. So just really quickly, if we check, for example, the HTTP log, you can see it's in JSON. Now, in this format, I would say it's not easily readable or not great for the human eye. So that's why using something like JQ can be a good option to display it in a more beautified, human readable format. There are a couple things that you need to keep in mind, though, because by default, you're going to end up with the Unix epoch format for the timestamp. And there are various ways to do the transformation for this one. But probably the easiest way to do it is, again, using JQ. I need to specify here the timestamp field. And whenever I deal with JSON logs, I like to just look at the first entry just to familiarize myself with the fields that are available. And then I'm going to do some magic here. I believe this command is in the cheat sheet that we have. And this will convert the timestamp format. So this is just an example of what you can do with JQ. It's a very, very powerful tool. The other thing that I like to do is just to have a sort of feel on what type of traffic is included, and for the specific protocols, is to run a few simple statistical commands against the data set. For example, for HTTP logs, I do like to just look at the host field, which will grab, in this case, I'm just looking at the first entry here, which will grab the host header information from the Zeek log. And as you can see, this is still included in quotes. I can tell JQ that I just want the raw data itself. And afterwards, I can run something like this to have a good feel on the top values. And the set of commands that I'm piping to, some of you might be familiar with this trick, is to have an ordered list, and I'm counting the number of unique occurrences. And then the last sort, I'm just telling sort to sort numerically, because the first field here is going to be a numerical value, the number of occurrences of a unique expression. In this case, I'm listing out all the host field information from the HTTP logs. And I can go probably, I hopefully will have enough space for the top 25 or something like that. And this gives me a quick overview of all the host headers here. Sorry, and I can browse through this one. I can do the divide and conquer approach at this point and pick out just the individual elements that might be interesting for me, and do further analysis on just that value, do further filtering, either using JQ or some other command line tools.
And so we are coming toward the end of our session. I want to be respectful of everyone's time on here. I know you did the extract of the files. If you can just do a directory listing real quick, and then we'll kind of
Sure.
pivot back and put a lid on this for everybody that's here.
Yes, I just wanted to show here the extracted files, and there is a naming structure here that Zeek creates. The file name does include a special identifier that you can use for further correlation, and also the type of protocol that you have. You can take this ID value, for example, and go back here and search for the ID value itself to see what other files it occurs. That's one of the cool features with Zeek. And the other thing is now you have all these files. So you can run further analysis against these and just see what is available. You can submit it to another tool. You can run additional tools against it, do higher level analysis. And maybe if you identify something that seems malicious or interesting, you can pass it on to your malware analysis team. And there are a ton of additional features that we didn't discover, but I think it kind of demonstrates the power of these tools and how you can use command line tools for a quick analysis.
Yeah, and if just let me kind of put a closeout for y'all. We were just looking at there. Keep in mind that was only after 300 and some megs, 354 megs of data. You can easily scale that process up very easily to many gigabytes, even terabytes, and being able to see that metadata is super helpful. And I just want to stress here, we have spent a grand total of $0 on licensing. Maybe you could argue VMware is the thing that we had to buy here to be able to use these most immediately. But there are a lot of these tools that are out there. These are just scratching the surface. I love when we can support multiple mission objectives with one tool. Gives me a single workflow, multiple values. And I don't want you to think that network forensics equals PCAP or network forensics equals Wireshark. Network captures from PCAP or Wireshark, those are both incredibly valuable to us, but it's not by any means the only way for us to do the work. And hopefully we were able to open your eyes a little bit on the different possibilities that are here of things that you can potentially look at. We cover all this stuff in Forensics 572 and a bunch of other courses as well. We strayed into a little bit on cloud territory, but really appreciate your time here today, kind of letting us share a bit of this with you. And hopefully you get a chance to experiment with some of those tools and let us know how it goes. So by all means, thank you, David, for spending the time with us, and appreciate you sharing that. And I hope you all get a chance to let us know how it goes in the comments and give us an idea of some of the things maybe you've discovered in your network traffic as well. Thanks, David.
Yeah. Thank you, and certainly go out and try out these tools. You will be amazed what you can achieve with them.
Yeah, absolutely. Cool. Thanks, everybody. Have a good rest of your week and a good rest of your day wherever you are. We enjoyed the time. Thanks.
Thank you.